So welcome back to this course. So in the last lecture we have seen the features of DC Expert and DC Ultra. So now we are going to see the other features of this design compiler mode, which are design compiler graphical. So these are basically, this mode is features with this optimization for multi-corner and multi-mode design. This reduces the routing congestion during synthesis. It helps to improve the area and timing correlation with the IC compiler. It also improves the runtime and routability in IC compiler. It has the ability to create and modify floor plans using floor plan exploration and physical guidance technology, which includes enhanced placement and capability to pass the seed placement to IC compiler to improve the quality of results, correlation and routability. Okay. So what are these basically? All these features are provided in design compiler graphical. As I said, that design compiler graphical mode is comes with DC Expert as well as DC Ultra mode. Okay. So that means before to start with the IC compiler, the corresponding gate level netlist that has been designed, or that has been done in such a way so that it can helps, that means for complex design. Okay. So this, in the advanced stage, these improvements in whether that is in floor planning or that is for routability or that is for placement, this that means the netlist preparation for, that means easier of these facilities in IC compiler. So this helps to reduce the runtime which is used in IC compiler. Okay. So that's why this design compiler graphical is that means most popular choice for using or to work on in design compiler mode. Okay. So to run the, that means design compiler graphical, so again we can run this, we can type this command dc_cell minus topographical underscore mode, that is in Linux or Unix cell. Okay. So in the next slide we will start another thing of design compiler, or another mode of design compiler, that is DC Explorer. Okay. So what is DC Explorer? So DC Explorer is basically used for as I said, that on system on chip design we have several complex blocks. Okay. So among those several complex blocks we can use some of the third party component. Okay. Third party IPs, intellectual properties, we can use. So whenever we are using a third party IP, so at that time the RTL description, or there are that means the detailed information of that IPs that are not being available to the designer. Okay. So that's why this DC Explorer that basically helps, okay, for developing the new RTL and then integrating it with the third party IPs in a easier way, so that the whole RTL block, whenever we are designing the system on chip, okay, so there might be some of the blocks which are that means the designed by the user, and some of the blocks are there which are being used by the third parties. Okay. So whenever they are being integrated into the design compiler mode, so this DC Explorer helps, okay, for developing the, and that means simpler RTL file in combination of both this RTL description of these third party IPs as well as the RTL description of that means the designer's RTL file. Okay. So it also improves the data, and it also fixes the design issues. It also creates a better starting point for RTL synthesis. Okay. So DC Explorer enables you to perform early RTL exploration, leading to a better starting point for RTL synthesis and accelerating the design implementation. So as I said, that time to market is an, that means essential factor in any ASIC chip design in the present day, Okay, so that's why and this system on chip basis, that means system design or ASIC design, this design explorer is an excellent choice, which basically gives you the earlier RTL exploration, okay, for reducing the time to market for or to reduce the design implementation time by accelerating the merging the third party IP's RTL as well as the design RTL into a simpler RTL, that means expression. Okay. So this DC Explorer, they are basically, it features with this efficiently performs what if analysis of various design, which basically configures the early in the design cycles, and it also helps to improve the, that means the speed of the development of high quality RTL description and the constant file, as well as it drives a faster and more convergent design flow, which are having this this third party IP's netlist file as well as the designer netlist file, and that all of this that can be again that can be used in the further mode, which is the backend mode, that can be performed in the IC compiler. Okay. It also creates and modifies the floor plans very early in the design cycles with access to IC compiler design planning. Okay. And another feature is that it can also perform the preliminary synthesis very quickly in compared to the full synthesis, yet gives you the timing and area results typically within the 10% of the final result produced by design compiler in topographical mode. So that means without doing the that means exact calculation of this area or this timing that means consumption, that can be done in design compiler topographical mode. So not doing this that means not doing that, it also gives you this quick synthesis results, that means in design explorer mode, that can be done, or which gives you, that means the results which had been produced by DC Explorer, that is within the 10% of the final result which has been that means obtained after the full synthesis part. Okay. So all these basically are that means features of DC Explorer. So whenever or that means we are designing a complex system, so at that time this DC Explorer is an that means very much a good choice for to focus on. Okay. So then in the next slide, there are in design compiler there are several compilers. Okay. So several compiler means one of that is HDL compiler. So that means why HDL compiler is needed? HDL compiler is needed basically in a design compiler. The input is the HDL file. HDL file means whatever design we are trying to that means we are trying to design. So that using that has been described using the hardware description language. Now that HDL file that has been given to the particularly that means design compiler to that is run in any mode, so that it can generate the corresponding get level representation of that particular function, okay, which has been mentioned through the HDL file. So this HDL compiler that translates this Verilog or VHDL description into a generic technology netlist file, which is used by design compiler to create an optimized netlist, and after the design, whenever it meets the functionality as well as this timing that means power and other design goals, you can read the get level netlist into IC compiler and begin the physical implementation. So what does it mean? So here one point is that is this Verilog and VHDL description that has been mapped or that has been translated into a generic technology netlist GTEC. So what is this generic technology library? So generic technology library is the that means basic library which has been provided by the Synopsys itself. That means as in the early of my that means lecture I said that the design that means whole this ASIC design flow, they are basically technology dependent. So technology dependent means I have to provide the corresponding standard cell library information to the tool before it's starting with. Okay. So that means whenever I am saying that okay, this logical expression that can be that means translated using this particular gate. So what are those gates available? So that information that will be provided to the tool itself from the beginning or before the starting of the this working with this tool. Okay. But here the thing is that this at the beginning whenever we are trying to run this design compiler, so at the first very beginning whatever function is there, that is mapped into a generic technology library which has been provided by the Synopsys named as GTech. So that means that logical expression now it has been converted into the GTech, that means that has been translated using the GTech library. So then after that this GTech library that will be converted into the another netlist file or another gate level representation using the actual that means technology file or this target that means technology file which I have been already provided to the design compiler in the starting of that. Okay. So that can be, that means there are two part of that, that means from the logical expression to the gate level representation there are two part, that means initially that will be converted or that will be translated into the generic technology file and then into the ultimate technology file. Okay. So this is the that means part of this that means this is the job of the HDL compiler which are used in this design compiler. So then there is another compiler, that is library compiler. So library compiler reads the description of an ASIC library from a text file and compiles the description into either an internal database or into VHDL library. The compiled database supports synthesis tools, the VHDL library supports VHDL simulation tools. So what does it mean? Library compiler, what do I that means need this library compiler? So library, the job of the library compiler is that means what I said, that I have to provide the corresponding technology library to the tool itself. That means what are there, what are the basic gates available or the basic components available in the library that has been compiled and that has been, that means that has been known to the tool through this library compiler whenever it reads those files into the design compiler environment. So it provides those information that these are the libraries or these are the basic gates or these are the, that means other arithmetic operations. So these are the components which are available in the particular library. So now whenever this function that will be mapped into the corresponding gate level netlist, so that will be now that will be used only those particular components which are used or which are being known through this library compiler. Okay. So that in Synopsys design compiler that can be stored in like in .db format or into .vhd format. Okay. So VHD format is basically it uses for simulation purpose, and .db file that has been used for this physical implementation purpose. Okay. So then there are another compiler mode, that is power compiler. So the job of the power compiler tool is that it offers a complete methodology for power, including analyzing and optimizing design for static and dynamic power consumptions. It performs the RTL and gate level power optimization and gate level power analysis by applying the power reduction techniques available in the power compiler tool, including clock gating, operand isolation, multi-voltage leakage power optimization and gate level power optimization. It also offers the designer to design very efficiently in power saving as well as area and timing, that means optimization during synthesis. So that means this power compiler tool is basically, as I said, that in in the earlier slides we have seen that this register retiming or this pipelining that has been used in DC Ultra as the advanced features of designing. Okay. So here this power compiler tool that helps like these methods like clock gating or operand isolations or this multi-voltage liquid power optimization, these are the techniques which are being used for optimizing in terms of power. Okay. So the job of the power compiler tool is that it helps or it do the, that means corresponding this technique, it applies this corresponding technique to reduce the power consumption in a automated way. That means this information is already provided to the tool. So whenever you need it, that means if you are not specification, that power consumption specification that is not meeting, so at that time this one of these technique will, or not only one, maybe along with one, maybe 2 or 3 or all of this will be used to achieve the corresponding desired specification. So unless and until it is you, as I said, that you have to run the tool recursively. So unless and until you are meeting, that means you are setting the constant that okay, this is my power consumption budget, so you cannot go beyond that. So at that time it will try to incorporate all these techniques to meet your corresponding constant. So if it is not, that means after applying all these techniques which are available to this tool, so after that again it will say you that okay, this much I can achieve, so after that or beyond that I cannot achieve, that is beyond my capability. Okay. So power compiler tool does that, it do only the, that means in terms of power consumption. Okay. So then there is another compiler which is a DFT compiler and DFT Max. So what is DFT compiler? DFT compiler is designed for testing. So we know that, that means whatever design we do, so at the end of the day we have to, that means after fabrication we have to test it. So to make the testing very easier, we have to take some of the precaution, we have to take some of the, that means we have to apply some of the methodology whenever we are designing the circuit, so that whenever we that means we have fabricated the chip, or we have, that means we have that chip in my hand, so at that time the physical that means testing of that chip, that became very easy. Okay. So this DFT compiler tool, it supports this Synopsys advanced test synthesis solution. Okay. It enables transparent implementation of design for test capabilities into Synopsys synthesis flow without interfering with functional, timing, signal integrity or power requirements. DFT Max is another tool set of Synopsys, that is basically DFT compiler is that comes with the design compiler itself, but DFT Max, that is a different tool like design compiler, where all this testing, that means that means initial testing or this advanced testing in the software domain, that means that means we are in the early stage of that. So in the software domain we can do, or we can apply all the test vectors to the corresponding design, and we can test our circuit that okay, it is performing absolutely well in all the testing environment. Okay. So that's why this DFT Max is a that means individual tool which has been used for advanced test solution. Okay, advanced testing. So DFT Max compression provides the synthesis based scan compression to lower the cost of the testing complex design, particularly when fabricated with advanced process technology. And designs using advanced process technology can have subtle the manufacturing defects that are only detected by applying at speed and bridging test in addition to stacked test. Okay. So DFT Max also that means it also reduces the cost by delivering 10 to 100x test data and test time reduction with very low silicon area overhead. So DFT Max enables complex scan synthesis in design compiler and complex scan patterns generation in Tetramax ATPG. So what is that means what is the usefulness of this DFT Max tool? So DFT Max tool, as I said, that as you can see that it provides or it can reduces the cost in a huge amount, like 10 to 100x text data it can provides. That means with very minimal number of, that means very nominal amount of area we have to incorporate to insert the corresponding scan chain for this stacket test or any other testing methodology. There are several testing methodology. Okay, so to that means make the physical testing very easier in the earlier, that means during the synthesis process itself, we can use or we can incorporate those testing plan so that the physical testing became very easier and low cost. Okay. So this is now we said that okay, this design compiler graphical. So design compiler graphical mode that has been named as design vision. So as you can see that design vision tool is a graphical user interface for the Synopsys logic synthesis environment and provides analysis tool for viewing, analyzing design at the generic technology and gate level both. Okay. And this design vision main window provides menus, dialog boxes for running frequently used design compiler commands. So it also provides graphical displays such as histograms and schematic for visual analysis. That means for the basic design or let's say that means medium complex design, you can use this that means visual version of design compiler, which is design vision. But for the advanced system design, you have to use design compiler in the command line interface. Okay. So most of the, that means complex system that has been used in using Tickle or any scripting language. Okay. For the basic start with, that means to start with the basic things, that means we can or you can use design vision. So in the lab also we will see how to use this design vision. So in the design vision, what is that means the difference here, whatever you will do in the graphical mode, in the background the corresponding command will run. Okay. Actually we are running the command mode, but we have not typed the command in the command prompt, but here whatever we will do in the graphical mode, that command will be automatically come in the graphic, that means command prompt. So this is the design flow of this design compiler. So as you can see that it starts with, it takes the entry as the HDL description, and then there is this HDL design compiler, then it passes through the HDL compiler. So HDL compiler not only convert or translate the corresponding function into the corresponding generic netlist file, it also check the syntax of the corresponding netlist file. Okay. So that means whether I have written the code, HDL code properly or not. Okay. So that is also the job of HDL compiler. So that means HDL compiler do all the job which is related to your RTL description file or this HDL description file. Then this after that means passing through this HDL compiler, that has been the corresponding logical expression that has been mapped to a generic technology which is GTech. So in the GTech, it do this timing optimization, data path optimization, power optimization, area optimization, then all these things can be done, and this timing closure also, all these things can be done. So this test for synthesis that has been done through DFT compiler, as I said, and this power optimization that has been done using the power compiler, that is also I mentioned in the very beginning. So here, apart from that, you see there are in the left hand side there are some other things which are like this there are that means the other things which are like this constraint, then IPs, design UI libraries, then this technology library, symbol library, then this DEF. Okay. So this all these files, basically this constant this library files that are being compiled, or that information is provided into the design compiler through this library compiler. So whenever it is compiled through library, so at that time this library information will be going to the design, that means design compiler. And in the right hand side, now you can see there are two other things, that means power analysis and timing analysis. and from there is this formal verification that has been done through formality. So formality is another tool for formal verification of the circuit. So in this course we will not see the that means we will not cover the formal way, that means formal verification or this testing, all this will not cover, okay. But these are the things which are already available using the that means or you can do in the Synopsys tool set, okay. So for today's lecture up to this one, so we will move on into this whole ASIC design flow into our next lecture, okay. Thank you.